Assalamualaikum warahmatullahi wabarakatuh, and hello all. Welcome back to the Mathematics Preliminary. Hopefully you already learned the first part, which is a vector analysis. Next, we go to the second part, which is coordinate system. Coordinate system is very important because when you want to solve any problem related to EMTs, you have to choose a suitable coordinate system, okay, to solve the problems. Right. So in this course, we have a three different coordinate system, which is Cartesian coordinate, cylindrical coordinate, and spherical coordinate. Right. What is a coordinate system? Okay, the orthogonal coordinate system. It has three surfaces, whether Cartesian, cylindrical, and spherical. When do the EMT analysis, the vector depend on space. Okay, this is the first part, and the second part, coordinate, to determine magnitude and direction of a vectors. For example, if we have a light source here, and then we want to find what is the intensity of light at this point. Okay, so that point indicate the coordinate at a certain regions, and then to find the intensity of light at that point, we need a vector analysis. Okay, as I mentioned in the previous part, the Cartesian coordinate involve the x, y, and z variable. Let's say you have a three different axes. Okay, normally we set x axis here, y axis here, and z axis here, but it can be changed. It depends on the equation. So for the time being, we set the coordinate system to be like this. Alright, so what is the value? Okay, the value on the Cartesian coordinates is varies from minus infinity to infinity, which is very big. Okay, we don't have limit. So the definition of the x cap x is equal to vector in x directions. Another one, we have x cap dx. So dx mean increment in x directions from one destination to another destination along the x-axis. Okay, for example, I want to measure from this point to this point. This one. This is dx, the increment. Okay, the Cartesian displacement. Okay, let's say, okay, we want to determine something on the Cartesian coordinate, maybe at this point. Okay, so from the origins to this point, how to express the dl, the increment, okay, this increment on Cartesian coordinates. Right, so what happened from origin to this point? Okay, by using the Cartesian coordinate, we can say that from this point, okay, is equal to the increment along the x-axis, and then the increment along y-axis, and then it's going up, the increment on the z-axis. Okay, this is the first part, second part, and third part. So this is how we define the displacement on Cartesian coordinate. So the first part, we have the ds, increment along the x-axis. So we have the vector x indicate the component x, and then we have increment along y-axis. Okay, this is the vector of y, unit vectors. Okay, and then we have a increment along z-axis, which is a dz. Right, this is how we write the dl in this case. Right, can you imagine we have a cubic. Okay, we have a cubic, and the cubic have how many surfaces? Basically, cubic has 6 surfaces. Okay, let's see from the figure. So let's say we have the surface 1 at the front, and then at the back also we have another surface. So surface 2 at the back, surface 3 here at the right side, and the left side surface 4, the top one surface 5, and the bottom one, okay, surface 6. We have 6 different surfaces. Well, for the cubic, okay, it's suitable to be analyzed using the Cartesian coordinate. Alright, so how can we determine, or how can we express the surface at certain directions? Let's say I take one, okay, the surface 1, this first surface. Okay, so for the surface 1, okay, if you take a little bit sample here, we can say the surface 1 is going towards the x-axis, right? The x-axis. So we define as d as x bar, mean that the surface facing the x direction. So we can define the surface as the increment along dy, y-axis, which is dy, and increment along z-axis. So we have dy and dz. And then the surface facing normal to positive x-axis. So we put x. And similarly, if we choose the right hand side here, we have the surface facing y-axis. Okay, so we rename as a dsy bar and equal to dx dz. So basically to determine the surface, so the increment along dx and dz, and the surface normal to y-axis. So we write as a y cap dx dz. And similarly, the surface on the top here, the surface phi. So the surface facing positive z-axis, and then the increment to find the surface is dx dy. And the directions is normal to positive z directions. Okay, this is a 3 different surface. But how about another 3 surface, which is opposite to the surface that we discussed? Okay, I take one. For example, for dz. Okay, dz, the opposite is at the bottom. At the bottom here. So how to define the surface at the bottom? So we can define as ds, okay, I put negative z, is equal to, okay, basically the surface normal to negative z direction. So we put negative z, and then the increment, the same increment with the top, right? So it has a dx dy. Okay, similarly, when we analyze the surface at the left hand side, surface 4 here, so it's equal to ds negative y bar equal to negative y, and then the increment is dx dz. And then the surface at the back along negative z axis, so this is a ds minus x bar is equal to minus x, and then dy dz. Okay, this is how we express the surface of the cubic on the Cartesian coordinate. This is very important. This knowledge is very important. Okay, hopefully you can understand the concept. Okay, this is as what I discussed before previously. Okay, another one is about the volume. The volume here. How to determine the volume of the cubic? The volume is actually a three-dimension, and then it don't have any vectors because we want the volume. Okay, so the volume is equal to the increment for dx, dy, and dz. Okay, this is the same thing, same explanations.